Elevators are amazing. I'm sure you've all been in one before. They're a fast and efficient way to travel vertically, be it to the top of a building or to the bottom of a cave. According to the Guinness Book of World Records, the world's tallest elevator is at the Mponeng gold mine in South Africa, which descends an astonishing 2.2 kilometers into the ground. But I feel like we can do better than that. Imagine stepping into a sealed elevator cubicle and shooting way up above the clouds and into outer space. No rockets, no burning fuel. A space elevator wouldn't quite work like the traction elevators we're used to, which would collapse way before reaching space. Instead, all we need is a single tether that extends up into space from a base in the Earth's equator and is roughly 100,000 kilometers in length, or in other words, over a quarter of the distance to the moon. A geostationary orbit, where an object is just far enough away to not get pulled back down towards the Earth, is located about 36,000 kilometers away from the surface, and that is where the main satellite is going to be. A counterweight at the far end of the tether will keep the center of mass at that geostationary orbit, so the whole thing doesn't fly away or crash into Earth. Finally, a climber will scale the tether between the main satellite and the Earth's surface. This entire system is going to be moving with the Earth as it rotates. Imagine yourself spinning on a carousel and holding out a rope that's tied to a small rock. Neither you nor the rock are actually moving relative to the carousel. But honestly, it does sound like a bit of a crazy idea. What do we gain from this in the first place? Well, currently, we use solid or liquid propulsion rockets to get anything into space. NASA's space shuttle consumed over 5,000 kilograms of fuel during takeoff. That is 2 million times the average fuel consumption of a family car. A space elevator trip could be much cheaper, take way less energy and way less fuel, making getting to space more accessible and more sustainable. So why can't we just build a space elevator right now? Well, if we look closer, we'll immediately see a plethora of issues. Things like long-term maintenance, collision with debris, international cooperation. But most importantly, what do we make the tether out of? As you can imagine, its length being almost 8 times the diameter of the Earth. For materials we consider to be strong, like steel, Kevlar, or even carbon fiber, such a task is way too stressful. If we make the cable thicker, closer to the geostationary orbit, where the maximum tension will be, it can better withstand the pull of the Earth and counterweight. Even so, for most materials, the maximum thickness at that point would be simply unachievable. We're talking thousands of kilometers thick. So what other options do we have? In 2003, NASA found that carbon nanotubes come the closest to being a feasible material for the space tether. The market for them is still rapidly growing, but so far, the maximum length produced on record is about 0.5 meter, which is off by a few orders of magnitude. But let's be real for a second. Will this actually happen? And if so, when? Loads of work and credible research has already been put in. Take NASA, for example. In 2003, they optimistically concluded that a space elevator could be operational in the next 30 to 50 years. That was 22 years ago. And since then, NASA seems to have lost interest and taken no further action. A Japan-based company by the name of Obayashi Corporation took matters into their own hands, announcing back in 2012 their plans to begin construction of a functioning space elevator this year, in 2025, with 2050 being the deadline for completion. However, on their website, they themselves admit that current technology levels are not yet sufficient to realize the concept. In the end, it is hard to place a definite verdict on the future of the space elevator. Theoretically, it is possible. But maybe there is a reason why NASA cut the funding. The material, long-term use, and financial concerns cannot be ignored. And there doesn't seem to be a way of building one just yet. However, there are other people working on it. More and more papers are coming out every year. So let this story serve as an inspiration of humanity's ambitious imagination and innovation. The space industry is still rapidly developing, and perhaps one of you will have a role to play in its next few chapters. Thank you for listening.